Citizens, for sure, want a safe journey on highways. One of the factors that can affect the journey safety is light facilities on the highway. This assessment focuses on making road light that generates energy from renewable energy. Wind power or wind energy is mostly the use of wind turbines to generate electricity. Wind power is a sustainable, renewable energy source that has a much smaller impact on the environment than burning fossils. Wind is used to produce electricity using the kinetic energy created by air in motion. On highways, sources of light are street light, light pole, lamp post, street lamp, light standard, or lamp standards, which usually put at the edge of a road or path.
So, innovation is to solve problems. But what is the problem? First, road in Malaysia lacks of light in some areas, especially rural areas. Light facility in Malaysia's highway normally located at major places such as tolls, arena, and urban areas. Lights are not located on the rural areas because of high cost of operation and power supply storage to cover long lengths of road. Due to that, this problem can threaten the safety of road users. Next, poor quality of light that require frequent maintenance and replacement. It can affect the safety of road users and also burden the public expenditure of urban construction.
To solve this problem, we have made an innovation known as Velolamp, which is for road users. Velolamp is a small wind turbine combined with a lamp that is mostly based on recycled materials, and it generates electricity using wind power. Velolamp is a word combination of velocity and lamp. Wind power is a popular, sustainable, renewable energy source that has a much smaller impact on the environment than burning fossil fuels. This work focuses on the assessment of potentiality of implementing small-scale wind turbines along the highways in Malaysia. Wind and solar sources are popularly integrated together in renewable energy systems because solar cells can produce the electricity needed during sunny days, while wind turbines can cover the electricity needs during windy days.
Research states that the distances between cat lights in highways are approximately 1 meter each. This is because the light reflection of the cat light are dim causes the distances of the light is close and eventually increases the usage of the cat light. This causes the spending for light facilities in highway increases, whereas for our Velolamp project, it produces a brighter light and causes the distances of Velolamp further. This eventually causes the spending for light facilities in highways decreases as the small usage of the Velolamp. As you can see on the background, this is the visual sketch of Velolamp located at the highway.
For the materials and tools, we mostly use recyclable materials such as RUCD and cardboard. We also use hot glue gun, a carbon bag, a capacitor, a light bulb, a dynamo, and wires. Then the processes. First, we will connect the dynamo and the capacitor together. After that, we will connect it with the bulb. Place the dynamo on the cardboard and attach the tip of the pen with the shaft and glue the combination on a larger cardboard. Next, glue the top of the bottle to the cardboard, followed by gluing 2 CD on top of the tip of the pen. And the product is finished. As you can see at the back, this is the visual sketch of the end product. As for the data collection method, it is by observing the differences of light intensities and the increasing of what for different wind speed, and the data will be recorded. The test is conducted with a fan to replace the wind force made by the transport. The fan speed will be changed conditionally to be observed.
For our Velolamp, the end product costs around 6 ringgit and 70 cents per project. Moreover, if our projects are going to be commercialized, it has many benefits for the road users, also the government. Our product is also affordable to be used by the government or any industries.
Next, for the results. It is shown on the table that Velolamp is working. The result of S1 shows that the light is dim as the wind speed is low, whilst S2 shows that the light intensity is partially dim with 14 meters per hour for the wind speed. S3 shows that the light intensity is bright, and S4 shows the most bright light intensities with 17.2 meters per hour for the wind speed. As for the hypothesis, The greater the wind force pushing the blades on the windmill, the greater the brightness of the light bulb.
As for the conclusion, the main purpose of our project is to make the highways be in a bright state and to reduce road accidents. We strongly believe that our Velolamp project will be used in the future by the government and many other industries. This is because our innovation project have a design that is easy to create and help people, especially road users. Our project is also environmentally friendly to be used. At the same time, it can ensure safety as well as be applied throughout the highways.